Welcome to QuantumFaultstack. This is a game that I've been working on, and with the help of Codex and GPT 5.6, I managed to really make some good progress on really the learning parts of the game. So there's a lot of things that have been added and modified and improved in this game. So the first thing is, what is this game about? It's basically a teaching tool disguised as a game. What it teaches you about is how a quantum computer can be kept stable in a fault-tolerant manner. So you have missions that you can select. You have a QPU bay where you actually upgrade your computer as you gain experience and where you gain credits and reputation. You unlock new capabilities. You go from a repetition code to surface code. You increase your logical qubit counts from ones to later into the 100,000s. And you can also increase the code distance to actually really improve the error correction capabilities of the quantum computer. Now, I'm not simulating the quantum computer by itself as running algorithms on it, but what I'm simulating here and what the game really is about is keeping the game stable, as in how does the operation stack around it really work? So when I select a mission, for example, the repetition D3 root contrast, this simulates basically what happens in a burst event. You have many errors in the quantum computer, and suddenly you need to correct them. So for that one, I have my quantum computer, I have a control computer, I have a readout ADC, an FPGA, a frame tracker, and they're all hooked up with connecting ports. By these ports, real packages are actually being sent. The quantum computer emits evidence in terms of analog signal, which is then processed by the analog to digital converter. The digital signal then travels to the FPGA, which is simulated in a simple way with also with a minimum wake perfect matching system, finds the right correction. Then there's a frame tracker which actually decides, hey, is this an error I need to correct and act upon now, or if I can do this later? And if I run this, you will see that the data is actually passing through into the QPU core. And from the QPU core, it gets evidence that can be processed. Now it's completely up to the player on how you actually process the whole thing. So you can really decide on, hey, I want to field tune my FPGA to really process X and Y errors, or I can actually really modify my FPGA into other systems. As you progress, you get basically, you get choices on what you want to improve upon. I'm going to select here temporal repetition decoder. It's a research that gets